Good morning everyone. I am Asma from 2nd B. I am going to talk about clocks. Humans invented the first mechanical clock in the 13th century. In the olden days, we measured time using sundial, water clocks, sand clocks, candle clocks, etc. Later, many types of clocks were invented. The latest clock is called the atomic clock and the quartz crystal clock, which tells the time very precisely. The word clock comes from the Latin word clocca, meaning bell. There are many types of clocks. Today, I am going to talk about the analog clock. Clocks which have hands and tell us the hours and minutes are analog clocks. The small hand is the hour hand. It takes 1 hour to go from one number to the next. It takes 12 hours to go around the clock. The big hand is the minute hand. It takes 5 minutes to go from one number to the next. It takes 1 hour or 60 minutes to go around the clock. Let us have a good time learning about clocks. Thank you.
Hello everyone, I am Akriti of class 2A. I am going to explain how to make a pendulum clock. First use thermocol, chart paper, numbers, icing stick and bottle cap. First we have to cut a shape of octagon for the head, and then we have to cut the shape of rectangle for the body. We made a long stalk and a big round for the pendulum. Pendulum is an oscillator which moves to and fro. We pasted numbers from 1 to 12. We made ice creams. We made hand from ice sticks and stuck it in the bottle cap. These clocks were used in 18th, 19th centuries. Thank you.
My name is Siddharth Lakshmisha from 4th B. Thanks for giving me this opportunity for this small presentation about math in space. The subject is so vast, so I limit myself to the basic concepts of length, weight, volume, time, and shape in Earth and space. More we explore the space, we realize how small we are. We start with length. This slide shows the planet's distance from the Sun in descending order. As you can see, Mercury is at 35,598 into 10 power 4 kilometers from the Sun, and Neptune is at 2,795 times 10 power 6 kilometers from the Sun. Mind you, everything's in kilometers. Now, as you saw, the values in kilometers were too high. So in space, distance is measured in light years. A light year is the distance light travels in a year. A light year is 9.46 times 10 power 12 kilometers. Example, our nearest galaxy, Andromeda, is 2.5 million light years away from Earth. So how long does light take to travel from the Sun to each planet? For Mercury, 3.2 minutes. For Neptune, nearly 4 hours. For Earth, 8.3 minutes. Now we go to weight or mass. If you weigh 25 kg on Earth, you'd weigh a mere 4.25 kg on the Moon and a whopping 62 kg on Jupiter. Why do the weight of the objects change in planets? Because planets have different masses. The attraction between object and planet depends on mass of the planet. Higher the mass of the planet, higher the weight of the object. Attraction between two masses is called gravity. This list shows how many times each planet is associated to Earth. For example, Jupiter is 300 times the mass of Earth. We go to volume. This slide shows the planets by volume in descending order. As you can see, Jupiter's radius 71,492 kilometers. Very high. Mercury's radius is a mere 2,440 kilometers. Looks like a joke in front of Jupiter. And Earth's radius 6,378 kilometers. Now, I am Siddharth Lakshmisha. The world population is 7.8 billion. Earth is one of the 8 planets in our solar system. Milky Way has billions of stars like our sun, and millions of galaxies make this universe. So as you can see how big our universe is and how small we are. Now we go to time. Now, how long is a day in planets? That's the time for one rotation around their axis. For Venus, 5,832 hours. For Jupiter, 10 hours. For Earth, 24 hours. Now, how long is a year in planets? That is the time for one revolution around the sun. Mercury, 88 days. Neptune, 165 years. Earth, just 1 year. Now, my last topic is shape. Scientists never know what the shape of the universe is. Luckily, an Italian scientist discovered the Fibonacci series. It goes on 0, 1, 1, 2, 3, 5, 8, etc. Now you must be wondering, what is this series? What's the speciality? The speciality of this series is that each number is the sum of the two previous numbers before it. When plotted on polar coordinates, it gives a spiral. As you can see, there are examples of Fibonacci spiral in our day-to-day life. A seashell, an egg, a fetus in a womb, a cactus, a hurricane, and even the Milky Way galaxy, once telescopes were invented, that is, are all Fibonacci spirals. Even scientists believe that our universe is also ever expanding like a Fibonacci spiral. Any doubt? Thank you.
Hi there. My name is Akshina from class 1B. Today I am going to demonstrate simple additions by using the arithmetic wheel. Addition is one of the 4 basic operations of arithmetic. It means putting together. This is the arithmetic circle. It's very easy to make it. We need 2 circles with different radius from 1 to 15, and we need to fix it in the center and put an arrow or a box that shows a number in the outer circle. Now let's see how to use this. We can use this for learning addition. You can put any number you wish, like 4. So 4 plus 1 equals 5, 4 plus 2 equals 6, 4 plus 3 equals 7. Like that you can learn arithmetic wheel. Now let's see how to use the arithmetic wheel to solve any small addition problems. Here I have 2 problems, and let's see how to solve it by using this wheel. So what is the sum of
8 plus 5. So we'll take 8 in the box. And we'll search for 5 in the yellow circle. 8 plus 5 equals 30. So we have solved the first problem. We have to find out 4 plus 11. Let us solve it. So let's go to 4. Let's take 4 in the box and search for 11 in the yellow circle. So I found 11 here. So 4 plus 11 equals 50. We can use this wheel to solve any small addition problems. Thanks for watching.
Hi, wondering what I'm doing? My mom bought groceries and checking the bills and seeing the money. Maths in daily life. Hi, I'm Rishabh Kumar studying in grade 5 study Lincoln International. Today we are going to talk about basic mathematics in real life. If we don't know basic mathematics, the shopkeeper will fool us. So, basic mathematics is important to us. We use it for many purposes like checking bills, constructing many homes, checking pulse rate and many more. Do you know even the plants use mathematics for their growth? Let me explain to you. When the plant grows like this, then the first leaf grows like this and second leaf grows like this, then so on. But the problem with the leaf is the new leaf blocks the sunlight from the old leaf. The old leaf can prepare food using photosynthesis, and then they gradually die. Imagine this is a stem and the first leaf grows here and the second leaf grows opposite 180-degree angle. Then the third leaf grows right on top of the first leaf and blocks the sunlight. Now let's try 120 angle. The first leaf grows here and the second leaf grows here and the third leaf grows here and the fourth leaf grows top of the first leaf and blocks the sunlight. No matter how many angles you try, it's gotta be the same issue, except one angle. If we want to find out what angle is that, we should know Fibonacci series. Fibonacci is an Italian who studied mathematics in 11th century. He discovered these patterns and it was named after him. It starts with 0 and 1. If we add these numbers, we get 1 as the answer. Now we should add the previous number with the answer. There comes 1 plus 1 is equal to 2. Then 2 plus 1, 3. Then 3 plus 2, 5. Then 5 plus 3, 8 and goes so on. If you add the previous number and the end number, if you have a series of 8, 13, 21, 34, this series also known as Fibonacci series. There is also another interesting fact about Fibonacci series. If you take two consecutive numbers and greater one to the smaller one, you get the number closest to 1.618, also known as the golden ratio. So now we are going to find out which angle the leaf grows better. This is a 360 degree. We are going to divide it by 1.618. We get 222.5
Also, we call it 137.5, which is known as golden angle. I have also made a sample angle, which is 137.5 degree. We use it for measuring the leaves. Imagine this is a stem. And the first leaf grows here, and the second leaf grows here. And the third leaf grows here. And the fourth leaf grows here. And the fifth leaf grows here. And the sixth leaf grows here. Now, do you see there's no blockage of sunlight? So, older plants can grow well and they can make their food using photosynthesis. Now, let me prove this to you with a live plant. Can you see? You can try this with any other plant around you. Hence, this Fibonacci series is called God's fingerprint. Okay, not just leaves. You can see Fibonacci numbers in many other things around us. To understand it, we must draw Fibonacci numbers as geometrical structures. For example, let us draw a square with length 1. Next to it, draw another square of length 1. So total is 2. Let us draw a square of length 2. And again we draw a square of length 3. Attached to it, then length 5, then 8, and so on. When we look at the numbers, they are all Fibonacci numbers. When we connect each square's opposite sides and draw an arc, we will get a spiral. And thus, we call it as Fibonacci spiral. Starting from snail's shell to site-node satellite image, even our galaxy is in a spiral like to the Fibonacci series. So, there is maths everywhere, even at our galaxy. Thank you for watching.
am Karnasagar of grade 2D and I have made a model of an alarm clock. An alarm clock is a device that can be made to sound at the time set. In advance, it is used to wake someone up. They are sometimes used for others' reminders. As well, alarm clocks alert me for my online class. Thank you.